I'm Vijay Kumar Pandit, a third year computer science engineering student from University College of Engineering and Technology, Vinova Bhave University, Hazaribagh. Under the guidance of Miss Jayalaxmi N, Dhanyal, I successfully completed my internship at Mortex, where our main project was an IoT-based home automation system. Today, I will share my complete learning journey from programming foundation to the final IoT project demonstration. Now, let's next after that I will discuss about what actually this internship was. This internship primarily focused on IoT home automation using the Blynk IoT cloud. The goal was to understand what IoT is, explore its real life applications, and design a functional smart system. We begin with C and C++ programming, then moved on to embedded systems, Arduino, and Blink IoT integration. Our tools include Arduino IDE, PICSIMLab simulator, and the Blink mobile application. Now let's move to the timeline of the internship. In day one, we learn about uh, C language, introduction of C, which includes introduction, data types, number system, data representation, modifiers, and mm, mm, there are lots of things which we have learned. Then in day two, we, we learn about control systems in C, like sign modifiers, if else, switch case, loop, and there are lots of decision making statements which we have learned, loop structures. Then day 3 we learn about operators, arrays, and jumping statement. In jumping statement we learn about break, continue, go to, and return. We learn about operators which are arithmetic, logical, relational, assignment, ternary, and bitwise operator. In day 4, we learn about functions and pointers, how to declare a function, what actually the function is, how to call a function. These type of things we learn. Then we learn about pointers. What is the use of pointer in C language? Then definition of pointer. Pointer is basically a variable storing address of another variable. Then in day 5, we learn about advanced pointers like pass by, reference, pass by arrays to function, returning a arrays. These type of things we learn. In day 6, we learn about pointer types, memory segments. There are many various types of pointers like null pointer, while pointer, constant pointer. Those pointers have their own specific task which used in C. Then we learn about strings in C, declaring strings, gets, puts. These are the function which used in C string in C language. Now next we learn about memory segment, how any data is stored uh, in C language. There are lots of different type of segment in which data is stored and execute, like stack, heap. These are the things. In day 7, we learn about storage classes, preprocessor directives, like storage classes. These are four types: auto, register, and static extra. And preprocessor directives. These are the uh, library which include various types of functions and statements, like has include, has define, macro definition, and conditional. In day in day 8, we learn about C++ language. In day 8, we learn about introduction of C++ developed by uh, then we learn about difference between pop and OOP concept. Pop is programming. mm, OOPS is object oriented programming, and pop is procedural object programming. What are the basic difference between them? Then also we learn about comparison between C and C++. Then we learn about class and object. What is class? Class is actually blueprint of anything. Object, then access specifier, like public, private, protected. What are the uses of these? How these are used in programming? These are things. Then we learn about constructors. What is the basic use of constructor? Constructor basically uses to initialize initialize an object. Constructor also have many types, but there are many types, but in any functions, simply default constructor are used. Then in day 9, advanced OOP concept, we learn about advanced OOP concept, which is object oriented. Now we learn about destructor, then pillars of OOP. Pillars of OOP is what are in the OOPs, like encapsulation, abstraction, inheritance, polymorphism. These are the things. Encapsulation is data hiding using classes, showing essential features. Inheritance is code reuse mechanism. Polymorphism is many form. Compile time, runtime. These are the things. Now that's about the basic programming foundation. Now let's move next to the project part. In day 1 of project part, we learn about what are the requirements for making this project, identifying project goals, required components like Arduino boards, sensors, jumper wires. These are the things. But in this project, we use simulators, PICSIMLab. These are the things. Introduction. Then day 2, we learn about introduction of IoT. What actually IoT is. Then in day 3, we learn about introduction to embedded system. What actually is embedded system? Basically, embedded system is combination of hardware and software for specific functions. Then we learn about microcontroller and microprocessor, Arduino architecture. architecture over here. This also we learn. Then in day 4 we learn about LED interface, how LED works, what is the use of LED in this project. These are the things like circuit diagram of LED and using digital pins. What is the use of delay function? These are. In day 5 we learned about CLCD interface, which is. Then in day 6 we learn about temperature sensor, which is LM 335 or DHT11. These are the temperature sensors which are used in this project. Then also we learn about displaying sensor output on serial monitor or LCD. In day 7 we learn about analog, right, and PWM, pulse width modulation concept using analog, right, application. And we learn also application of this analog, right, and PWM, which is motor speed control and LED brightness. After those class happened, next we learn about serial tank. What is the use of this serial tank in this project? Using serial communication like serial begin, serial print, these things. Water level sensor integration and displaying level data over serial monitor also. Then we learn about Blynk app integration. How to integrate Blynk app with this project. Like first we have to install this app, then create project, then generate the authentication token, then use this token in code integration with the Arduino, then controlling devices via mobile. Overall, what we learned, like we basically learned C programming, introduction to object-oriented programming, introduction to IoT and embedded system, Arduino IDE and PICSIMLab simulator. Small projects required for final uh, like LED controlling using LDR interface, and how to integrate Blynk IoT integration. How to integrate this Blynk IoT app with this project. Now let's move to topics covered in C programming. As we know that we learned about fundamental use of C and its application, number system, data types, conditional statements, pointer functions, storage classes, arrays, macros, header files, and preprocessors. Then we also learned about IoT. We learned many things in IoT also, like basic definition, which is IoT is a network of physical object things and it with sensors, software, and other technologies that connect and exchange data with other devices, an embedded system over the internet. There are lots of application of IoT like smart home automation, smart agriculture, healthcare, industrial IoT, and smart cities. This in embedded system definition, an embedded system is a microcontroller or microprocessor based system designed to perform a specific dedicated task. There are types of embedded system is small scale like remote controls, and medium scale is smart application, and complex is automotive systems. The applications are automobile, engine, control, airbags, medical, pacemaker, monitoring systems, industrial, robotics, and these things. Now we learn about Arduino IDE, which is a code editor for programming. Now let's move to the next part. uh, we also learn about what is the use of PICSIMLab. PICSIMLab is a real-time emulator of development boards. PICSIMLab stands for PIS, PIC Simulator Laboratory. It is an open source microcontroller simulation tool used to test and debug embedded system without needing physical hardware. It works closely with MPLab X, and these are some many uses of these are microcontroller simulation, hardware in the loop testing, learning and teaching tool, debugging, support, peripheral simulation, and cross-platform. These are some uses of this PICSIMLab. Now let's move to the next part. What topics we learned related to IoT is like we learned about what is IoT, then structure architecture of IoT and its application. We learned about embedded system, uh, Arduino IDE, what is the use of PICSIMLab simulator, how how LED works, and how what is the use of LDR sensor. Basically, LDR sensor is used for detecting light. Then we learn about basic program of controlling LED using LDR, about CLCD and its working, and a program to interface CLCD. Then we learn about introduction to Blynk IoT application. This application is used for just controlling your hardware component. Then final project. Then let's move to the final project implementation. Now comes to the highlight of the internship, the IoT-based home automation system. This system allows user to control electrical appliances like fans and lights using the Blynk IoT Mobile App. It works through a Wi-Fi enabled microcontroller, Arduino, and connected to the cloud. When a button is pressed on the Blynk app, a signal is sent over the internet to Arduino, which then activates or deactivates the appliances. This demonstrates how IoT bring automation, energy efficiency, and user comfort into modern homes. Now let's move to the project demonstration part. This is the Arduino IDE user interface. I created separate files for each component. The main file contains the Blynk template ID, device name, and authentication token received when registering the device on the Blynk IoT cloud platform. Here we include pre-processor directives required for Ethernet set, temperature system, and serial tank modules. There's a function for the cooler pin and another for the heater pin, both displayed on the Blynk app for control. Then the outlet and inlet valve function handle serial tank water flow. The update temperature the update temperature reading function updates real-time temperature on the gas. When the temperature exceeds 35 degrees Celsius, the heater automatically turns off and send a notification via Blynk. In the handle tank, in the handle tank function, we manage water volume If the water level drops below to 2000 liters, hmm, if the water level drops below 2000 liter, the inlet valve turn on automatically. When the tank reaches 3000 liter, it closes automatically, ensuring smart water management. This setup function now this setup function runs once to initialize modules, and the loop function repeatedly calls these subsystems for continuous operation. Then the next file is garden light control. It includes functions to initialize and control garden light brightness. During the day, brightness decreases at night. It increases all managed using LDR sensor. We also have header file defining macros for sensor spins and constants. Similarly, the serial tank code initializes the tank, its volume, and control inlet outlet valve. Now let's move to the uh, these are the files. All these are separate files. Now let's do the project demonstration part. First, I compile the code in Arduino IDE using Sketch. Export compile binary. Once compilation is successful, I open PICSIMLab, load the compiled .hex file, and run the simulation. Here you can see the Arduino UNO board with its connected components. CLCD is this is CLCD character LCD displaying current temperature around 27 to 34 degrees Celsius, and serial tank volume mm, which approximate 3000 liter and full. Then LDR sensor and LED managing garden light, Ethernet shield providing internet connectivity, then temperature control system with LM35 sensor. Now connect. Now let's. Now I will show you how my smartphone connects to the Blynk IoT app. The app has two tabs. Tab 1 cooler button, heater button, temperature gauge, and notification panel. Tab 2 is inlet valve control and outlet valve control for the serial tab. I will turn on the heater, which measures the real-time temperature which given by the PICSIMLabs sensor. then turn off the heater, then turning on the cooler. Mm, then inlet valve control and outlet valve control. Uh, Currently, the temperature is 27 degrees Celsius. Tank volume, that's all things are working smoothly. When I press on button, then tank become full. After after filling the tank, they give the notification. Please turn off the tank. So this is all over the project demonstration part. Now let's move to the overall feedback and conclusion part. Overall, this internship helped me a lot, strengthen my programming fundamentals in C and C++, gain real-world experience with Arduino and IoT devices, and also build a mindset for innovation, logic development, and continuing learning. Through this, working on the final home automation project, improved my debugging, design thinking, and integrating skills. It also taught me the importance of automation and innovations. Overall, this internship has been a major stepping stone toward becoming a skilled IoT and embedded system developer. Thank you for watching my presentation, and also thank you for Mortex Technology.